So what about the tooling provided by the virtual machine itself? JStat is a command line tool that lets us run various monitoring commands. It lets us look at things like class loading, for example. But the commands we care about here are all to do with the garbage collector. So for example, we can run commands to look at the garbage collector's capacity. So how much memory has been allocated for each part of the garbage collector. We could run a gcutil command, which gives us various statistics on the garbage collector. Or we could run the full gc command, which shows information about an ongoing garbage collection, such as how many garbage collections have happened and some timings around those garbage collections. There are also other commands around causes of the garbage collection and various other timing commands we could also run. The general form of JStat is something like this. We do JStat, we pass it an option, we pass it a process ID, and the process ID here we need to find out. This is our Java process ID. So we can pass JStat an interval, and this gives you a time in seconds or milliseconds, and that tells JStat to produce this output at that interval. And we can also give it a count, and again this is optional. If we pass it an interval but not a count, then the count defaults to infinity. We can basically tell JStat how many lines of output we require here. We'll also find that JStat can work with remote JVMs as well. So we can pass this a URL that identifies the Java VM on a remote machine and monitor that virtual machine. So to demonstrate JStat in action, we have a reasonably simple Java application here. This Java application uses the GCMe class that we've seen previously. This is quite a large class here. So when we allocate instances of this class, we'll get a large memory allocation. It's got 10 long variables inside the class. When we allocate an object of this class, we'll store that reference inside an array. And the array holds 1,000,000 elements. And we store it at some random location inside the array. Initially, we'll be storing new objects at empty slots inside the array. And those objects will be referenced by the array. So those objects will not be garbage collected. But eventually, as we fill the array up and we start allocating objects, we'll overwrite already existing references. And those existing objects that are no longer being referenced will be GC'd. What we should see are a number of young garbage collections happening and a number of old garbage collections happening as this memory gets freed. So firstly, if we run this application, we see the application is running. We're printing out a dot here every so many allocations. I think it's every 100,000 allocations. So we can see this thing is ticking over quite happily here. And then what I now want to do from another command prompt is run JStat and gather some information about this application. So before we do that, we need to find the process ID of the application. And we do that by running JPS. And JPS shows us the current Java applications that are running here. An allocation overwrite has a process ID of 5456. So if I run JStat minus gcutil 5456, then we should get some information about the application. So what we're seeing here are some percentages. So S0, S1, E, O, and M are percentages of the total memory space used by these various spaces. So survivor space 0 and 1, Eden space, old space, something called the meta space. So Eden space, for example, is using up 100% of the young generation space at the moment. We're also seeing some counts. So YGC is the number of young garbage collects that have happened, and FGC is the number of full garbage collects that have happened, and then the T values of these are the times for those the average times for those garbage collections. If I run GC cause rather than GC util, we'll see similar figures. Time has moved on here, so we can see there'll be many more young garbage collection counts and many more full garbage collection counts. We'll also see the causes of the garbage collections as well. LGCC was the cause of the last garbage collection, and GCC is the cause of the current garbage collection. And in both cases, we see the garbage collector ran because there was an allocation failure, i.e. there was no memory available. If we run GC capacity here, this will give us information about the amount of memory allocated for the various regions within the garbage collector. So these fall into minimum, maximum, and current for the young generation and for the old generation. So MGC-MN is the minimum allocation for the new garbage collector, and NGC-MX is the maximum allocation for the new garbage collector. NGC is the amount of memory currently allocated for the new garbage collector. S0C and S1C are the survivor space allocations, and EC is the Eden space allocation. And if you total up EC and the SCs, they should total to the allocation for the new generation. 8704 plus 8704 plus 69952 comes to 87360. So again, for the old region, we have OGC minimum, OGC maximum, OGC allocated, and OC, which is the capacity for the old generation. So finally, what about GC stats? So if we run jstat minus GC against this process, then currently we'll get a single row of output. And again, we're showing information about each of the generations here. So S is a survivor, E is Eden, O is old. So we have S0C and S1C are the capacity for the survivor spaces. S0U and S1U are the utilization for the survivor spaces. EC and EU are the Eden capacity and the Eden utilization. And OC and OU are old capacity and old utilization. And if we look off to the right here, we'll see we have a young YGC, that's the number of young generation garbage collects, and YGCT is the time. FGC is the number of full garbage collects, and again FGC time is the time for the full garbage collects to happen. So if we run this at an interval, let's say every second, and get it to print out 10 rows here, then we should see the number of young garbage collects rising, and we should also see the number of full garbage collects rising as well. So notice the young garbage collect count goes from 1837 to 1862, and the full garbage collection count goes from 1825 to 1850. And we notice the times for these things are increasing as well. So we can use this tool to monitor the number of garbage collections that are happening, and we can also use it to monitor how quickly they're happening, and we can use it to check the way our application responds to different garbage collectors.